Good morning, friends. My name is Niro Kumar. So today we are discussing about the series that we are starting yesterday. First thing that we are learned that acoustics. What is acoustics? Now in my second things, that is second period or second lecture in Jain classes, you are here welcome by the Jain classes and myself is Niro Kumar. So today we are discussing our second topic that is called superconductivity. So, what is in your mind that what is superconductors? Or superconductivity is what? So, superconductivity is a phenomena which is much different from the conductivity as some of the best conductor like gold, silver, and copper do not show superconductivity at any temperature, whereas some ceramics which are insulators at room temperature shows the superconductivity. So first thing in your mind that what is conductor, what is insulator, what is semiconductor and what is superconductor. So if we consider the first things, conductor. So what is conductor? So conductor is what? The material which passes through electricity at room temperature, which is approximately 25 degrees Celsius. That materials are called conductors. There are so many metals are behaving like a conductor, and the mercury, which is semi-solid, it is also like a conductor. Second things, what is semiconductors? So if we apply some amount of energy to that material and the electricity is going to pass at particular temperature, that system is called or that materials are called semiconductors. Examples are silicon and germanium. Third is insulator, the material which do not pass the electricity, that is called the insulator. Now in your mind that we have the three types of materials, it is conductor, semiconductor and insulator. So why we require the superconductors? So some phenomena which is not possible with all the three materials. That's why the superconductor is going to or consider in the picture as a fourth state of matter, that is superconductor. So how these superconductors are made, that we are discussing here in this particular things, then the use of it and the different types of phenomena is considered with the help of superconductor that we should discuss or we will discuss in this particular video. So superconductor contains the two properties. One is zero electrical resistivity and second is the Meissner effect. So what was thing is that what is zero electrical resistance? Resistance means the oppose the flow of electricity. It is called the resistance. So the zero electrical resistance means 100% electricity passes out from that. And second is Meissner effect. If these two conditions are followed by the material, then the material are called superconductors. Superconductivity has vast potential importance in technology as current can flow through a superconductor without any thermal losses. So what is the temperature dependence of resistivity? So the resistivity suddenly drop to zero at a particular temperature is known as critical temperature Tc or remains zero. So the critical temperature for a mercury is 4.2 Kelvin. Below this critical temperature, mercury is superconducting, whereas Above this temperature, it behaves like a normal conductor. So different superconducting materials have the different critical temperature, but the nature of the variation in resistivity with the temperature remains more or less similar. The first thing is zero electrical resistance. So a voltmeter was connected across the specimen to measure the potential difference across the specimen. The temperature of the specimen is then lowered. It was observed that below a particular temperature known as the critical temperature, the potential difference across the specimen suddenly dropped to zero. Cumberland owns a superconducting ring was kept in a magnetic field. When the magnetic field was switched off, current is induced in the ring due to change in magnetic field. So there was no voltage source connected to the ring. The current in the ring is expected to decrease. The changing current will produce a changing magnetic field, which in turn will induce an EMF. A current in another test coil held close to the superconducting ring. The electrical resistivity of superconductors may be assumed to zero. The decay time of the current in superconducting solenoid is not less than 10 raised to 5 years. So next we are considering the second properties, that is called the Meissner effect. So when a specimen is placed in a weak magnetic field and cooled below the critical temperature, the magnetic flux originally present in the specimen is ejected from the specimen is known as Meissner effect. So in 1993, W. Hans Meissner and Robert Hochschild found that when superconductors are cooled below their critical temperature in the presence of magnetic field, the magnetic flux is expelled the interior of the specimen and the superconductor becomes a perfect diamagnetic. It is known as the Meissner effect. So in what happened if we consider the normal conductor? So if we consider that this ballpoint pen is a normal conductor, if we apply the magnetic field on it, then magnetic field lines are passing from this. But if this magnetic field is superconductor, so there is no magnetic fields are there. So the magnetic field lines do not pass this ball pen. So this phenomena is called Meissner effect. So the magnetic induction inside the specimen B is equal to mu 0 H plus M, that is equal to mu 0 1 plus xi into H, where mu 0 is equal to permeability of a free space and M is equal to intensity of magnetization, where H is applied magnetic field. So at T less than Tc, then B equal to 0. So mu 0 H plus M equal to 0. So that is M equal to minus H. So susceptibility of the material is xi equal to M by H, that is equal to minus 1. That is equal to magnetic susceptibility. From this we can say that a superconductor exhibits perfect diamagnetism. Next is the properties of superconductors. So first one is electrical resistance. It is very low and of the order of 10 raised to minus 7 ohm into meter. Effect of impurities. So they are added the superconducting elements The superconducting property is not lost, but the Tc value is lowered. Third is isotopes effect. Tc is directly proportional to 1 divided by square root of m, where Tc equal to critical temperature or transition temperature, where m is equal to the isotopic mass. So in 1950, C.A. Reynolds and X. Maxwell find out this isotope effect. Next is magnetic field effect. So minimum magnetic field required to destroy the superconducting effect is the critical magnetic field, Hc. So Hc is equal to H0 1 minus T by Tc whole square. Next is critical current density Jc and critical current Ic. So it can be defined as the maximum current that can be permitted in a superconducting material without destroying its superconducting state. So critical current density is a function of temperature, that is colder the temperature for a superconductor. So the more is the current it can carry. So IC equal to 2 pi R Hc. So that is equal Jc equal to Ic by A, where R is the radius of the wire, Ic is equal to critical current, and Hc is the critical magnetic field. Next, comparison between type 1 and type 2 superconductors. So type 1 superconductor and type 2 superconductors. So in type 1 superconductors, they exhibit the complete Meissner effect. In type 2 superconductor, they do not exhibit complete Meissner effect. In type 1 superconductor, they show the perfect diamagnetic behavior. In type 2 superconductor, they do not show the perfect diamagnetic behavior. So in type 1 superconductor, they have only one critical magnetic field. In type 2 superconductor, they have the two critical magnetic field. In type 1 superconductor, there is no mixed state or intermediate state in case of the material. In type 2 superconductor, mixed state or intermediate state in the material. So in type 1 superconductor, soft superconductors are there. In type 2 superconductor, hard superconductors are there. In type 1 superconductors, lead, tin and mercury is there. In type 2 superconductor, NBSM, that is the niobium and strontium and niobium and tritium is there. So these are the difference between the type 1 and type 2 superconductors. Next we are going for the temperature at which the normal conductor is transferred into the superconductor. This phenomena is called critical temperature. The effect of pressure and stress on superconductor is also there. So they are found to exhibit superconductivity phenomena on increasing pressure over them. The increase in stress result in increase in Tc value. Next is the persistent current. Steady flow of current in a superconducting ring without any potential deriving, it is called the persistence current. Use of the Meissner effect. Whether a particular material is superconductor or not, small magnets repulsed by a bigger superconductor. However, in air, it is known as the leviation effect. A small chip of superconducting materials hangs on a big magnets. This effect is known as the suspension effect. The leviation effect is the utilization in the operation of the Meissner swings. So today we are discussing about the superconductors, so that we can stop here in our basically second part. of the things we can discuss the further. So it is already 15 minutes going to complete it. We are stop here right now. So thanks for watching my channel. My name is Sahan Kumar and you are connected with the Jain classes.